Okay, I've got a nice little video we're going to do here today. Kind of short and sweet, AP Calc. Um, all right, so here's the deal. A very often used and tested topic has to do with determining the equation of a line that is tangent to a curve at a point. The process is pretty simple. In this case, I'm going to use a function yx squared plus 6. And in fact, what I'm going to do is I'm going to make it more accurate depiction here to try and help the presentation. So here we have something resembling y equals x squared plus 6. Okay, so we're going to want the tangent at a point, but there's an additional twist here. We're going to want the equation of the line that is tangent to the curve and goes through the point 2, 1. Um, I don't see this problem worked on a lot with the students, but it just came up with one of my students, so I want to put out a quick little video on this. Number 2, there's oftentimes there are going to be 2 tangents and possibly even more, but this one we're going to solve for this line called L1, and I'll leave L2 to the reader. So here's basically the approach. The problem solution we are looking for is an equation of the form y equals mx plus b, representing the equation of this line. All right, so how are we going to get there? Well, let's take a look at what we know. This is just a tactic I try and teach my students when they feel they're confused, and that is to make sure that they document what they know. Well, we know our function is y equals x squared plus 6. It's highly likely we're going to be interested, and we will be, in the derivative of that curve, y prime equals 2x. Now, what should kind of jog the student's mind here is, given that we have an external point, we are likely going to make use of the definition of the slope, y2 minus y1 over x2 minus x1, as well as looking at the definition of the slope as being the derivative of the curve. All right, so how are we going to do this? Here's the first key, and this happens a lot in calculus, where you're looking at a point. In this case, I'm going to call this P1, where this tangent line is tangent. Let's call it PT. That's the tangent point. Well, what are the coordinates of that point? What do we know? Well, we don't know hardly anything, but we do know we can represent it as x f of x, which then really can be specifically represented as x comma x squared plus x. And the observant students may now begin to see where we're headed with this. We know here for this specific curve that the slope is equal to 2x. That means x being the tangent point, which we don't have other than this generic representation. However, we do have the general equation for the slope because we now in fact have 2 points. We have x comma x squared plus 6, and we have 2 comma 1. So let's play that out. That slope is going to be y2 minus y1 over x2 minus x1. Okay? Well, now, where do we go here? This is pretty much the point that's going to pull this all together. This is the general representation of the slope. Well, we also know that the slope is the value of the derivative, 2x. Well, there we go. we set 2x equal to x squared plus 6 minus 1 over x minus 2. That will give us the value or one of multiple values of x that will be the solution to this problem. Okay, well then let's play this out. 2x times x minus 2 equals x squared plus 5. Remember, the solution to the problem that I just mentioned is the equation of that tangent line. And again, I'm not going to go into this one for the second line. We're just going to do the first one here today. So let's continue on. We have 2x squared as we distribute property this equals x squared plus 5. X squared minus 4x minus 5 equals 0 because we know that this is the approach that we must use in order to solve a quadratic. Well, from your basic first year algebra class, you will notice that this factors into x minus 5 times x plus 1, which leaves us as x solutions of 5 and negative 1. Well, how can we have two solutions? Because we have 2 points of tangency. Again, we're only going to be interested in one of them. And from the graph, we can see that this point here is going to be 5 comma something. Well, what is that something? Well, that should be pretty easy to know. If the x value is 5, then the y value is x squared plus 6, which is going to give us 31. Well, we're almost done, because to finish up here, we want to utilize the point slope form. Y minus y1 equals m times x minus x1. Now, keep in mind that we could use either this point, which is the point of tangency, or we could use the 2, 1, as long as we had the slope. So what's everything that we need here? We got x1, y1, and I'm going to use the point of tangency, which is 531. Well, what's the slope? Well, we know the general form of the slope is 2x, and that means the derivative or the slope is going to be 10. So therefore, just plug and chug now. Y minus 31 equals 10 times x minus 5. And let's get this into slope-intercept form. As we just do the little bitty part of algebra here. And we're going to end up with y equals 10x minus 19. And there we go. There's the equation of the tangent line, of this tangent line, of what we called L1. So there you go. So this is nothing special here. This is using everything that the student already knows. Even if you haven't seen this problem before, the AP students are expected to be able to think outside of the box and should be able to do this problem. Let me know if you have any questions. Thanks.